Alright, so in this video we'll see how to use series expansions to solve a second order linear ordinary differential equation. Okay, so we let y equal to the sum from n equals 0 to infinity of Cn x to the n. So the Cn is just the coefficient of x to the n. That's fine. Now, I'm going to differentiate this once. And in doing so, I'm just differentiating with respect to x. So differentiating with respect to x gives me n Cn x to the n minus 1. And a second differential, n minus 1 Cn x to the n minus 2. Alright, and now I'll substitute these back into my equation. So I'll get 1 minus x squared times this sum, n times n minus 1 Cn x to the n minus 2, minus 2x times this sum, n equals 0 to infinity, n Cn x to the n minus 1, and then plus 2 times this sum, n equals 0 to infinity, Cn x to the n is equal to 0. Okay, now I'll expand these brackets here. So I'll have timesing by 1 just stays as it is, n minus 1 Cn x to the n minus 2. Now timesing by x squared will add 2 to the power of x, so this will become minus n equals 0 to infinity, n times n minus 1 Cn x to the power n minus 2 plus 2 is n. Here, I will bring the 2 in as well and multiply by x, and in doing so, this will become x to the power n. So this will be minus the sum from n equals 0 to infinity, 2n Cn x to the n, and this is, as it is, Cn x to the n. Okay, so now I have these three terms are all, oh, I forgot the x here, are all x to the power n's, but this term is x to the power n minus 2. Now I want to get them all consistent. I want them all to either be x to the power n or x to the power n minus 2, or maybe even something else, but I want them all to be the same. And the reason for that is, if I can get them all the same, then I can equate the coefficients on one side to the coefficients on the other side. Now clearly on the right hand side, the coefficient of x to the n is 0. So I will be setting the coefficient of x to the n on this side to be equal to 0. But first I need to make this a power of x to the n. Now you'll see that this is x to the n minus 2, so I'm probably going to make the dummy substitution by letting n become n plus 2. Now before I do that, there is something important that we need to notice. This series here starts at n equals to 0. If I substitute 0 in, the first term, the n equals 0 term, will also become 0 because it's 0 times whatever is left over, which is going to be 0. And a similar thing will happen if I substitute n equals 1 in. This will be 1, but this here will be 0. And so if this is 0, the whole term itself is 0. So my first two terms in this series, the n equals 0 and n equals 1 term, are both equal to 0. So having them here in this limits of my summation really doesn't change anything. So I can change this from a 0, I can rub that out or cross it out and make it 2. So if I do that, then that's going to help me as I make my dummy substitution. So I'm going to do that dummy substitution now, and I'm going to let x equal n plus 2. Sorry, n equal n plus 2. So first, before I deal with the limits, let's substitute wherever I see an n, putting in n plus 2. So n plus 2 minus 1 will be n plus 1, Cn plus 2, x to the n plus 2 minus 2 is x to the n. Now for my limits, this is n equals to 2, but after I make my substitution, it's going to be n plus 2 equals 2, which is equivalent to saying n equals 0. So now I'm starting at n, my pen is messing up, n equals to 0. And well, if n is equal to infinity, then n plus 2 equals infinity, and so it's the same thing. I'm going to infinity. Okay, and these all remain the same. n equal to 0, and n minus 1. Now I'm going to combine them all into one summation. So that'll be n times n minus 1, which I get from here. Now I've got a minus out the front, so this becomes plus 2n. This will become minus 2, and the entire thing will be multiplied by cn x to the n. And that will be equal to 0. And now I can see that I have only x to the power n, and so I can equate the coefficients. I'll have m plus 2, m plus 1, c to the m plus 2, minus, here I have also a coefficient of x to the n, so it's n times n minus 1 plus 2n minus 2 times cn equals 0, because the coefficient of x to the n on this side is 0. Alright, let's do a little bit of rearranging. m plus 2 times m plus 1, cm plus 2. Now, I'm going to bring this over to the right-hand side and simplify it a little bit. I will have n times n minus 1 plus 2 into n minus 1 if I take a factor of 2 out from here. And then I can take a factor of n minus 1 out from these terms, and I have m plus 2 n minus 1 cn. And then if I divide by m plus 2 on m plus 2 times m plus 1 on both sides, I'll have cn plus 2 equals, that will cancel with that, and I'll have n minus 1 divided by n plus 1 c to the n. So here I have a recurrence relationship between coefficients of x to the power n and x to the power n plus 2. Now you can see that these differ by a difference of 2. So when this happens, the series is said to decouple. So the series solutions decouple into odd and even solutions, odd and even solutions. And they're defined by C1 and C0, which are defined by C1 and C0. So the odd will be defined by C1, the even by C0. Let's do the even series first. So if n is equal to 0, then C2 equals negative 1 on 1 times C0. And you're going to see that I'm going to leave these like this, but you'll see why I do that. Now, if n is equal to 2, then C4 is going to be, well, 2 minus 1, which is 1 over 3, times C2. But what's C2? That's negative 1 times 1. So that's 1 on 3 times negative 1 on 1, C0. Let's do another term, n equals 4. So I'll have C6 equals 4 minus 1 is 3. 4 plus 1 is 5, and so that's C4. But what is C4? C4 is this thing, where that is a 0. So that'll be 3 on 5 times 1 on 3 times negative 1 on 1, C0. And now you'll see that this 1 will cancel with that 1. And here I have negative 1 on 3, C0. This 3 cancels with this 3, and this 1 cancels with this 1. And each time I'm cancelling with the one that's sort of diagonally below it. And I'm left here with negative 1 on 5, C0. Now, let's see what this series would look like. I'm going to call it YE because it's the even series. That's going to be equal to, well, the first term will be C0. The second term will be C2 times x squared, which is negative C0, negative 1 on 1, so negative C0 x squared. And then the next term will be C4 times x to the 4, which will be negative 1/3 C0 x to the 4. The next term will be negative 1/5 C0 x to the 6th, and so on. Now it's a plus here, but it doesn't really matter if I wrote a plus or minus because I'm just going on. I can factor out C0, and so it's 1 minus x squared minus 1/3 x to the 4 minus the 5th, x to the 6th, and so on. Okay, now if I had to, but I don't in this question, it's not specified for us, but if I had to infer the formula for the equation of the coefficient of x to the power n, well, what would that be? If I have coefficient of x to the power n, if I have the coefficient of x to the n, it has value. Well, what's the value going to be equal to? We can see that it's going to be the negative of 1 divided by the number that's less than the power. So it would be negative 1 over n minus 1 and minus 1, where n is even, because we can see clearly that n is even in all of these, in this series. All these terms have an even power. Okay, so that would be our solution for YE. Now what about if it's odd? So let's start with going back up to see our recurrence relationship. There it is. Now if n is equal to 1, what would I have? I would have C3 is equal to 1 minus 1 divided by n plus 1, which is 2, C1. Now this is 0 times C1, so it's 0. What about n3? That's C to the 5, or C sub 5, is equal to 3 minus 1, which is 2, divided by 4, times C3. But what's C3? C3 is 0. And if I continued on, every subsequent term would be equal to 0. So CK is equal to 0, where K is odd. And K has to be greater than or equal to 3. So what does that mean? That means that my odd series is equal to C0 times x plus C3 times x cubed, but C3 is 0, plus C5 times x cubed, C5 times x to the 5, but C5 is 0. And so I will continue going on and getting zeros, so my series is just C0 times x. And this is very easy to check. If you just sub this back into the equation, you'll see that this is very obviously going to be a solution. So what is my general solution? Well, my general solution would be the following. Since this equation is linear, where's the equation? Since this is linear, I can use a superposition principle and add up my two solutions. So the general solution is going to be y equal to a times ye plus b times y0. Now, this I should have written as C1, not C0. My bad. Let's write it better. C1x. Okay. Now, this is a constant, and C0 is a constant. So these are also constants, so I can just absorb these two constants into a and b. And I'll have a times 1 minus x squared minus a third x to the 4 minus a fifth x to the 6, and so on, plus b times y odd. Y odd was C1x, but I'm absorbing C1 in, so it's bx. And that's the final answer.